Hi everyone. Welcome to this video where we discuss about consistent hashing. So if you have gone through my videos, in some topic or the other, we have introduced this concept and we have discussed in high level about consistent hashing. But in this video, we'll be discussing in details about the nitty-gritty and the working of consistent hashing. So to achieve horizontal scaling, like to distribute the data among multiple servers, since a single database server is not sufficient to hold a huge amount of data, it is important to distribute the data efficiently and evenly across servers. So suppose in order to achieve that, what we do is, let's say I have servers, let's say I have S0, S1 and S2, three servers with me. So let's say n equals to 3, and for that matter, for example, I have 6 key value pairs, let's say k1 to k5, which will be stored in these servers and evenly distributed. For this, to find for a particular key what will be the server index, so we use a formula is like we hash this key and then modulo with the number of servers to get the server index. So suppose let's say we use a hash function for key 0 and this value is let's say 15 and we have number of servers. So for let's take this to be some 17 to better understand, because 15 was divisible by 3 actually. So for if we take 17 and if we divide it by 3, so modulo 17 modulo 3 is 2. So key 0 will be mapped to server 2. So in this way, let's say in server 1 I have key 1 and key 5, server 2 I have k0, k2, k3, and in server 1 let's say I have k4, and this is more or less evenly distributed. But in order to make it look more distributed, let's say I put this k3 in server 1. So these values actually are calculated by the hash values and they are done modulo. So this is the modulo hash or the rehashing problem, the rehashing function which we use to assign our keys to a particular server. So the formula which we use is this: to hash the keys into a particular server and to store the keys in a server. So suppose we will consider two scenarios. Case 1, when the number of servers is fixed. When the number of servers is fixed, so we have a huge influx of keys, key value pairs, we have a huge influx of data, and we want to have the data being evenly distributed in the multiple servers. So let's say initially I had a single server and it stored values with characters, let's say A to Z, and there were 100 rows. And let's say in order to scale horizontal scaling, because the number of entries are huge and this database server cannot support this amount of data, so what we do, we introduce let's say two servers, database 1 and database 2, and we evenly distribute 50 rows each in each of the database. And the distribution is such that let's say database 1 stores data from with characters A to P and database 2 stores characters from Q to Z. And suppose in our initially the data which we had 80 rows of let's say only A, and remaining characters we had the remaining rows. So what will happen in this scenario is like 80 rows will be mapped to database 1 and the remaining 20 rows will be mapped to database 2. So we have an uneven distribution of data here. So this is one of the problem which we have if we keep the number of servers fixed, but we have a huge amount of data which is coming and being stored in this database server. So this is problem 1 which we faced. Let's say another problem is like, let's say another scenario in which the servers are not fixed. We say, let's say introduce, since huge amount of data is coming, there is load balancer, we need a extra database server cache to store our data. So we introduce server 3, or let's say another server is introduced. So in this case, what will happen is the hash function to basically the modulo function to check whether which key will that which server actually the key will be hashed to which server index, we will be having 4 instead of 3 which we had earlier. And thus what might happen is, like, suppose initially I want to find the value for, let's say, keys k0. So initially it was k03 and it was mapped to s2, but here since now it is 4 and it is mapped to s1, so there will be a cache miss whenever I want to read the value pertaining to the key k0. So what we have to do before any read operation, we have to redistribute the data as per this modulo 4 and store the data in each of the servers and thereby perform a read operation. So in this example, what we saw is, what the problem is, since it was only 6 keys, so this redistribution of data is not much of high latency, but in real world scenario we have millions of data and with millions of data present in the database server. So whenever a server is added or server is removed, we need to redistribute the data every time before we perform a read operation, or else there might be cache miss happening. A huge amount of cache miss will be reported. Okay, so these are some of the problems which we faced in a normal hashing function, like if we perform a normal hash, simple hash, and to find the server index for a particular key. So these two problems which we face. So in order to overcome this problem, the workaround which we have is basically this consistent hashing. So what is this consistent hashing? So the main motive behind this consistent hashing is to reduce the number of data movement whenever a server is added or server is removed. So the main motive is to reduce the data movement whenever server added or removed. So in consistent hashing, we have a hash space. So let's say I denote it by array. So let's say x0, x1, and it goes up to, let's say, xn. So if we use a hashing algorithm, say SHA1, in cryptography, its space ranges from 0 to the power 160 minus 1. And this is represented in form of a circular ring. So what do we mean by circular ring? So let's say for our time being example, we suppose we have 0 to 12, 0 to 11, basically 12 hash space. So if I put it in a circular ring, so I will have, like, I'll partition the spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's say 0, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 hash spaces, 12 in total 12 hash spaces. And we use a hashing algorithm. So here we hash two kinds. Earlier we hashed only the keys to put into the server. Here we hashed first the servers based on, let's say, we hash based on IP addresses or based on the name of the server, and we assign them to this hash value. So let's say I have server 1, server 2, server 3, total 4 servers, and I hash them using my SHA1 hash function, or you can use any other hash function as per your use case. And let's say this maps to 2, and correspondingly they have their own hash values, and randomly they are assigned to a hash space. So let's say this is S0. So here I have S1, here I have S2, and here I have S3. So this is one hash of the servers which we perform. Second, the hash we do is we hash the keys. So using the same hash function, so let's say I have this key k0 and it maps to a hash value of hash space of, let's say, 3. So in this way I put let's say I have 4 keys So K0, K1, K2 and let's say K3 is here, mapped to 11. So how do we assign the servers now? So the next question is, how is the keys, how are the keys assigned to the servers? So for this, what we do is we perform a clockwise movement on this hash string, and the first immediate server which a particular key encounters, that key is assigned to that particular server. So for in this case, when we move clockwise, so key K0 encounters server S1 and this is assigned to server S1. Similarly for K1 it is assigned to S2, for K2 it is assigned to S3 and for K3 it is assigned to S0. Okay, yes, this is assigned to S0, and by this we have assigned our keys to our server X. Okay, so this reduces. So suppose, how does this solve the two problems which we faced actually? So the first problem which we, if you remember, we just discussed is like we had uneven distribution of data in both the databases, but in this case there the data is distributed and each server has its own keys. But there might be a situation, so let's say I'll draw the consistent hash string once again, and let's say my server 0, server 1 is here, server 2 and server 3 is here, and the keys are assigned like this: K1, K2, K3 and K4. So if we follow the assigning method of moving clockwise and assigning the keys to the immediate server which we encounter, so all these keys will be assigned to S2, and thus we are facing the problem 1 situation in which the data is unevenly distributed, among the database servers or the database cache servers. So what is the solution? What is the workaround for this is, so what we do is, apart from physical servers, we also introduce virtual servers. So the solution is introduce virtual servers which in turn map to this physical servers. So let's say S1 has its virtual server here, S11, two virtual servers for S1, another virtual server for S2, another for S3, and S0 has another virtual server here, let's say. So what will happen now, if you see, K1 will be mapped to S1, K2 and K3 will be mapped to S2, S1 again, but this is a virtual server for S1, and K4 is mapped to S2. Thus, the data has been more or less evenly distributed among the servers instead of being concentrated to a particular server. So, by introducing a virtual server, we have solved the problem 1 scenario. The second scenario is like, suppose a server is dropped. So, this is solution 1. So, the second problem which we had was like, if we add a server or if we remove a server, we have to redistribute the data every time. But if you see here, so let's say I have this ring and I have this servers here, and let's say the keys are distributed like this: K1, K2, K3 and K4. So what will happen? So for initial assignment, K1 is this, K2 is this, and K3 and K4 is assigned to S2. And now suppose server 1 is down. So this is down. So what will happen is, this K2 will be assigned to S2. So initially in the previous scenario, what we had to redistribute every key depending on the number of servers present, since our method of finding the server index using a simple hash value depended on the number of servers. But here only we had to move this key to be assigned to a new server, and thus our distribution of data movement has been minimized to a lot lesser value. So this is the solution to find the next immediate server to assign the key. And this value actually, if we look mathematically, this is 1 by nth percentage of total number of keys present. This, the data movement is represented by 1 by nth percentage, where n is the number of servers of always, if whenever a server is added or removed, this amount of data will be moved to be assigned to a new server, which is much less than the amount of data movement which we had using a simple hashing algorithm. So by this we solve our two problems which we faced, and thus consistent hashing has been seen a great improvement or great solution for non-relational databases like Amazon's Dynamo DB or Apache Cassandra. All these use consistent hashing for their data partitioning for minimal data movement whenever a server is added or removed depending on the load of the data. So they have been using consistent hashing. So more or less this is an overall high level overview of how consistent hashing happens. So now if you go through this video and if you relate the concepts which we discussed in our various playlists where we used consistent hashing, let it be for data partitioning or data replication or server assignment, so you can relate why we had done those things and how consistent hashing is helpful in those scenarios. So thank you for watching this video. Stay updated for more such interesting videos, and I'll see you in the next video with such a new topic.